Let's solve a problem involving definite integral and its application to acceleration, velocity, and position. So the problem states that suppose a particle's acceleration in meters per second squared is a of t is equals to 12t squared minus 6 with initial velocity v of 0 is equals to 5 meters per second and initial position of s of 0 is equals to 10 meters. We need to find the s of t and find the particle's position after 2 seconds. So analyzing the problem, before we get the second one or define the particle's position after 2 seconds, we need to find the s of t since it's just simple substitution afterwards. Now, to solve it, we need to find the given first in which we have the acceleration the value of the initial velocity and the initial position. Now that we have the given, we could easily calculate the first one, which is the s of t. So first is we need to know that the integration of acceleration is equals to the velocity. So velocity is equals to the integration of our given 12t squared minus 6. To integrate it using the power rule, this is basically 4t cubed minus 6t plus c. Okay, why did we get that? 12t raised to 3 over 3. Simplify, 12 divided by 3 is 4, then 6 is constant, so I just add the variable t. Now, we could get the final value for the velocity of t since it is given that we have 5 meters per second. If the value inside v is 0, so v of 0 is equals to 4 times 0 raised to 3 minus 6 times 0 plus c is equals to 5 meters per second. Now this is cancelled and cancelled. Now c is equals to 5. Then we could just substitute the constant with 5. Now we have the value of the constant, which is 5. So this is our answer for v of t, but that's not what we're looking for. We need to find the s of t, which is the position. Now, if the integral of acceleration is the velocity, then the integral of the velocity is the position. Again, the integral of the acceleration is the velocity, and the integral of the position of the velocity is the position. Now to find the position, we have the calculated equation t 4t cubed minus 6t plus 5. Integration, of course, then dt. Then just integrate it. We would get 4 divided by 4 is 1. So t raised to 4 minus 6 divided by 2 is 3. T squared plus 5t plus c. Now we have a given position, which is s of 0 is equal to 10 meters. So we could use that to get the constant. So s of 0 plus 0 raised to 4 minus 3 times 0 raised to 2 plus 5 times 0, in which all of those is 0. So we could easily cancel them out. We don't need to write that m there. So it's basically constant is equals to 10. So t raised to 4 minus 3 t squared plus 5 t plus 10. So this is the final value for s of t. So this is the answer for s raised to 3. I mean s of t, which is the equation for the position. Now, we're not done yet since we need to find the particle's position after 2 seconds. So we could just substitute it. So 2 raised to 4 minus 3 times 2 raised to 2 plus 5 times 2 plus 10. This is 16 minus 4, 12 plus 10 plus 10. 20 plus 16 minus plus 8, 24. So our final answer is 24 meters. So it's very easy to get the second one if we already get the letter A. Now this is our final answer. So the position is, or the equation for the position is t raised to 4 minus 3 times t raised to 2 plus 5t then plus 10. Then if we substitute the value of 2 or the position after 2 seconds, the position is 24 meters. So that's it for this problem.